Today's probably going to be a little bit long. There's a lot of material to cover over in chapters 2 and 3. I'm not going to cover everything in the book, but I'm going to cover the important things. And then if you want me to cover something that I don't, just ask. I can give you examples or try to explain things that seem complicated. But we'll start with the project. Make sure you can create a project. I'll share a screen with you guys here in just a second. Any questions before we get started? All right. I'm going to share screen, so brace for impact. All right. We're going to create a new project. Click on File, New, click on Project. Make sure you have Visual C++ selected, and then do the empty project and put your name on it. And store that project somewhere that is not the C drive, unless you're working on your own laptop or whatever. Make sure you uncheck this box. We don't want our solution in a separate folder. All right, once your project is open, you'll click on Source Files. Yes, sir?
I'm not seeing empty file here in Visual C++.
Empty project?
Yeah.
We're going to add the source file, C++ .cpp file there. Some people here like you to call that main. And then we're going to start with our basic code. Pound include IOStream. Pound include is a directive. A directive is a message to the compiler. All right, who knows what a compiler is? Who doesn't know what a compiler is? Everybody does and does not know what a compiler is.
A loose understanding, let's call it that.
It just runs the program?
No. It takes the C++ code that we write and it, through a chain of events, converts it into machine code that the processor can understand. That's ultimately ones and zeros. That is the only thing the processor understands. It does not understand I and O and S and T and all that stuff. Anyways, it is a program that interacts with our program and the hardware. Pound include is a directive. It is a message to the compiler. It says, hey, we're going to be using some other programs along with our program. We're going to include IOStream. IOStream is a library, some code that has already been written for us to use that allows us to get input and output in our own program. So that is a directive. A namespace is a group of names, basically. It could have functions or variables or different things in there, but we're going to be using the standard namespace. That's what STD stands for. And then we need our main function. The program always starts in main. That's kind of like a starting point for just about any C++ program. We always start in main. For our output to the console, we use cout. Follow it up with this operator, the less than symbol. 2 of those in a row, that's called an insertion operator. We're going to insert some text here. Go ahead and run this, make sure everything runs correctly. Oh, we forgot to do one thing. We need to go over here to the project, whatever you named your project, right click on that and go down to properties. In the properties window, you need to click on the arrow for the linker, click on system, and then go over to subsystem up at the top and change that to console. We all there?
I'm not seeing it actually on my side. I do have server explorer expanded on my left side, but I'm not seeing the name of the project.
Did you get to the properties page?
Not yet.
Did you find your project over here?
It's
Alright, now you can run the program by holding down Control and pressing F5. And if you've done everything correctly, you should get your message out here at the top in the console window. Now, if this window closes immediately, it's because you did not set the subsystem. Let's talk about comments. In a program, you can write comments. These can be, little notes to yourself or notes to other programmers. You can type a single line comment by doing a double slash. And it's a good habit to comment your code. A good habit to comment your code. Especially if you're writing something complicated or abnormal or it involves a lot of math. Just a quick little message there to explain what you're doing. If you come back and look at your code a year later, it's a lot easier to understand if you made a comment. Or if you're sharing code with the team. If you're writing some really weird abstract stuff, you want to write some comments. So we use comments to make notes for ourselves and other programmers, and we also use comments to get rid of code that we don't want to delete it, but we don't want to run it. So if I want to take that out of my program, but I don't want to delete it, I can turn it into a comment. And we probably use this method more than the other. Like, the more you get into programming, your code gets long and complicated. Some part of it's causing bugs. You might just want to turn that part into a comment. That way you don't lose all your work, but it doesn't affect the program. So when you do that, it's called commenting out. I'm going to comment out that line. That means I'm going to make it ignored by the compiler. The compiler does not read comments at all. You can also do a multi-line comment by typing /*, and then anything that is typed in between the /* is considered a comment. All completely ignored by the compiler, just a note. Moving on. Variables. We have several different types of variables in C++. Variables are where you store information. Right? If you prompt the user for their name and you need to store that name somewhere, you need a variable to hold that information. Does everyone know what a variable is? Should know, should know. Okay, what are the 7 primitive variable types that we have? Int. What is an int? Whole number. How many bytes? 4 bytes. Largest value we can store here. If I want to stick 1 billion in here, can I do that? Can I say num equals 1 billion? 1 trillion? Can I do a trillion? No. We run out of bits. You've only got 4 bytes. The biggest value you can store here is 2 raised to the 32nd power. 32 bits. And really you only get half of those values because half are reserved for negatives. So if I say 2 raised to the 32nd power, that's the largest value that could be represented by 32 bits. And by default, half of these are reserved for negative values. So if you divide by 2, subtract 1 from that, that is the largest value you can store in an integer. 2 billion and some change. If you want the whole 4 billion, you can put unsigned in front. Then you give up all your negative values. This can no longer store a negative, but it does extend the range all the way to 4 billion. All right, what are some other data types that we have? No. Who said string? No. String is not primitive. How do you spell primitive?
Something like that. That's close enough.
Primitive. Can't spell. Anyways, a string is a combination of what? Char. Char is the primitive. Char. The chars are, if you're going to write a single char, it goes in between single quotes. And that can be any symbol from the ASCII table. A string is an array or a sequence of char. A string is not primitive. And if I ask you on the test, list the 7 primitive variables and you put string on there, it will be wrong. Who's going to put string? Yes, you will do it. Who else? Someone else will do it. Lots of people do it every time. Even though I tell you right now don't do it, people will do it. What else we got? We got char, we got int. Float. What is a float? You can think of this as a small decimal. Anytime you need to represent a decimal, you need at least a float. And what's the counterpart to the float?
Double.
The double. The float's 4 bytes. The double is 8 bytes. To represent really large numbers with a double. What else? There's 4. Boolean. Well, we call it a bool in C++. True or false? Now you can assign the Boolean, the true or false value. You know, using the words true or false. But in reality, the compiler sees this as one of two things. Zero or non-zero. Zero or non-zero. So what if I say this equals -1? That's non-zero. Is that true or false? This is true. Zero is false. Anything that is non-zero is true. What else? Integers, chars, float, double, bool. We've also got a short. Small integer. We have a long. Also 4 bytes. That's 7, but if you want, you can declare a variable to be a long int. This is an 8-bit integer. 8-byte, 64-bit integer. And you can type unsigned in front of any of the integer types to give up your negative values and double the range on the positive side. Now let's talk about string, because we will use strings. They are not primitive, but they are commonly used. So if you want to use a string, we'll go up to the top and do pound include string. And then you can use the string class to create arrays of characters or sequences of characters that represent strings. Okay, but it is in green. It is not a primitive. That is actually an object from the string class. All right, I'm going to scrap all this and we'll write some new ones. We'll have an int called num, and we'll have a string called name, and we will prompt the user to enter their name and their age. We're going to get input from the user in the console. We use cin, and we use the extraction operator. It's the reverse of the insertion operator. We have to store that input somewhere, so if I'm asking for the name, what do I put here? Name. That's a string. A name is a string, so it seems appropriate. Put name right there. And we can do age. Put the integer there. Sorry, I called it num. then we can use those variables. We put the insertion operator in between each break in the string. So we'll say hello, whatever their name is, and then something about how old they are. So we can use those variables in other parts of our program once we have some information stored there. So go ahead and run that, test it, make sure it works. So it says enter your name, put my name, put my age. It says you're 36 years old. Works just fine. So we got plus, minus, divide, multiply, and no. Modulus. What does modulus do?
Remainder.
Returns the remainder. Is that a math operator? Some people think that this is an exponential operator because I think it is in BASIC, but it is not in C++. Okay, that is not the exponential operator. Don't use it as such. Let's do a little adding program. Let's get two numbers up here. We'll have num1 and num2. And instead of enter name, we'll do enter the first number. We'll take in num1 and enter the second number, the first number. We'll take in num2. We'll add them together. And we'll store that in a variable called num3. Num3 equals num1 plus num2. And our cout statement down here, the sum of the numbers is num3. If I'm not ending this with a string, I can't put a backslash in, so I put the end line. And run that, make sure it works. First number 10, second number 20. I expect to see 30 for output. It works just fine. Like I said, there's some other stuff in this book in chapter 2 that I'm not going to cover, mainly because this is a review, but it might be a good idea to look over the summary. We'll take 5. can go walk around, stretch your legs, get some fresh air or whatever, and then we'll start on chapter 3. Let's roll on with chapter 3. Chapter 3 is over loops and decisions. So we'll start by looking at our relational operators. We have 6 relational operators. Less than, greater than, less than or equal to, greater than or equal to, not equal to, and is equal to. Relational operators evaluate 2 different things. They compare something. You have something on the left, something on the right. It compares the two, and it returns a value of true or false. All right, it's important to remember that. Ultimately, this turns out to be true or false. So if I say 5 greater than 3, is that true or false? 5 is greater than 3. That is a true statement, so ultimately this means true. And if we do a C out here, we should see some indication of that. What did I do wrong? This may have to go in parentheses. Yeah. We get a 1 there. That's non-zero. That means that is true. Let's flip it around. Now that is a false statement. We all agree that's false. 5 is not less than 3. If we run the program, we should get a 0. And there's our 0. So that's what relational operators do. They're going to compare 2 things. They're going to return true or false. And we can do the same thing with variables. We can say int num1 and comma num2. That gives us 2 integers. We'll say num1 equals 45. Num2 equals 13. And then we can compare 2 variables. And we'll use a different operator. What's the output?
True.
Num1 does not equal num2. That is a true statement because num1 is 45 and that is not the same as 13. We get our 1 that's checking out correct. Memorize these 6 relational operators. That'll probably be on the test. Loops. Sometimes we write code, we need that code to run multiple times, and we don't want to write it multiple times. In fact, some code runs indefinitely, and to do that we create what is called a loop. It runs it, it loops back, and it runs it again. So we have 3 basic types of loops. I think the simplest is the while loop. So while, open and close parentheses, open and close braces. In the parentheses, we'll get a condition. You can use one of these operators and compare 2 values, or you can just type anything non-zero. As long as this statement evaluates to true, this loop will continue to loop. Alright, so anything we type in here will just continue to happen over and over and over again. And we call this an infinite loop. So And if you run that code, it should just take off like a bullet, and you see it's repeating that statement over and over again. Now, if we take away the true up here, we put a condition. Let's go create our number again. We'll say num equals 1. And we'll base our loop on num. We'll say while num is less than 10, we loop. So is 1 less than 10? Yes. This condition is true, our loop will run. Inside the loop, we're going to bump up num. We can do that by saying num plus plus. Plus plus adds 1 to the value. So how many times does this loop run? 19? 9. 9 times. It will go up every time until it hits 10, and then is 10 less than 10? No, it is not less than 10. That's a false statement, so the loop ends. And yeah, the loop will run. Of course, that's a false statement now because it's not an infinite loop. It's a conditional loop. The other loop is a do loop. A do loop is just like a while loop, except for it will always run at least once. To write the do loop, type do, you open and close your braces, and then you put while at the end of it, and you put your condition there, and it ends with a semicolon. This is the only loop that ends with a semicolon. And then here we can type straight up false. This is just a false statement, and this loop will still run at least once. And then if you wanted to, you could put your condition down here and base that on num or any other thing that you wanted to. And then it would work basically the same as a while loop. But it checks the condition after the loop, so it always runs at least once. These are good for validation. If you want to get input and then make sure that input is valid and then move along, a do loop works out pretty nice. If you guys have questions, just let me know. And then our last loop is the for loop. And the for loop is a loop that is designed to run a specific number of times. You're going to write for, you're going to open and close your parentheses and open and close your braces. And inside here we have 3 expressions. We're going to initialize with some sort of counter, normally I. And we'll start that at 0. Then we put our condition. As long as this condition is true, this loop will run. This condition is usually based on this variable, but doesn't have to be. It can be anything that evaluates to true or false. We'll just say I less than 10. And then the last one is the increment. This changes the variable I. And normally you will see I++, but it could be I minus minus or I plus equals 2. What do you expect to see for output? 0 through 9. 0 through 9 it is. Every time the loop runs, this I++ is executed, and it bumps I up by 1. I starts at 0, and it goes up to 1 and 2 and so on until this condition is false. When that condition is false, the loop ends. Alright, see if you can modify this loop. I'll give you a few minutes to mess with this. Modify the loop so that it starts at 10 and counts down to 0. That will give you the same result. So lots of ways to do this. What if I only want the odd numbers? Only want the odd numbers. How do we do that? Is 10 odd? 10's even, so what should we do first? So we'll change that to a 9. That's our first odd number. What else? We'll subtract 2 here because we don't want all of them. We only want every other one. So the easiest way to do that is to say minus equals 2. That's the same thing as saying I equals I minus 2. You can type it out the long way if you'd rather. That gives you just the odds in reverse. Or you can write it like that, same thing. Any questions? We're good with loops? So here's some classic questions that you'll probably see again. When do you use a while loop?
When you want to do it a set number of times?
No.
When you want to do it at least once?
No.
You want to do it continuously?
Yeah, you don't know how many times you need it to happen. You want to do it, you want it to run on a loop, but you don't know how many times. It's got to be based on some condition that has to be met. When you've got a condition that needs to be met, but you really don't know how many times it needs to run, use a while loop. Now, when do you use a do loop?
When you need to run at least once.
At least once. Got to run at least once, otherwise we don't know. Use a do loop. When do you use a for loop?
When you know the exact number.
You know exact number of how many times it needs to run. Commit all that to memory. Let's look at decisions. If we want to make a decision in a program, we need if statements. If statement looks like this. Inside the parentheses, we have a condition that will evaluate to true or false. If it is true, then whatever's inside the braces will be executed. If that condition is false, it totally skips that block. So if we run that, we should see our string. The condition was true. And if it's false, we will not. So the conditions in here work just like the loops. You can use any of the operators up here, compare values. Ultimately, whatever is being checked will come down to true or false, 0 or non-zero. If it's non-zero, this block of code will be executed, and you can put anything you want in this block of code. You can put more if statements, cin, couts, loops, whatever. This block of code can be as big as you need it to be, and it can handle as many statements as you can type. But if the condition is false, none of it will be executed. Let's look at a simple application here. Cout, enter a number. And we'll create our num, and we'll say cin num. Let's change our cout statement. Let's say between 5 and 10. Alright, now we need to know if they actually entered a number between 5 and 10. So we'll say if num is greater than 5, we'll display the number is valid. Not sure who that is. Alright, what's wrong with this? What's wrong with my logic?
It also has to be lower than 10.
Also has to be lower than 10. Alright, so we're going to have to check two things. If we want to check two things, we could put an AND operator in here. That's 2 ampersands. And we have to write a second condition. It has to be a complete condition. We cannot just say num greater than 5 and less than 10. That's not complete. That's only a fragment. You have to write num again. It's not that smart. So we'll say num greater than 5 and less than 10. Now, should 5 and 10 be inclusive? No? It says between.
So it should not include this.
It's up to you. If you did want it to be inclusive, you put the equal sign on there for both of those. I don't know if that should say in between. Anyways, not important. And when we run that, if I enter a 3, I get nothing. It skips the code. If I enter the 7, it says the number is valid. What if we want to handle the case that they entered the 3? We'll put the else. If the condition is false, the else will be executed. Well, what we can do is put this in a loop. So if they enter invalid numbers, we'll keep asking them for numbers until they enter a valid number. So I want this to run at least once. I'll make a do loop. I'll write do up here at the top. Open brace. Close it down here. While we can just type true. And the do loop ends with a semicolon. Now, what's this program going to do if I enter a correct number? It'll say the number is valid, and then what?
What will the program just end?
How could it end? The condition on this loop is true.
keep going until it's a invalid number.
It will keep going indefinitely, regardless of what I type in. What we could do is move our condition down here, do a copy and paste, instead of hard coding that to true. We've got another problem though. It doesn't recognize num. Num was declared inside the loop, therefore its scope does not exist outside the loop. So the quick fix there is to move the num up above the loop. Alright, this is one way to do it. There's other ways to do it. But let's see if this works. If I put in a 1, it's not valid. Well, that didn't work at all.
You need to swap the operators in the while statement.
Swap the operators. Like that. If I put in a 1, 1 is less than 5, and 1 is greater than 10, that would still be false. When you're working with the AND, both conditions have to be true. Any other ideas? This was a bad idea. Who did this? Let's go back to true. If they do enter the correct number, we can break out of the loop using a break statement. Break. Break will break you out of one loop. So now if I put incorrect numbers in there, it keeps prompting me for numbers, and if I put a valid number, it says the number is valid and the program ends. We need an OR statement, not an AND. So with AND, both of these have to be true, or the entire statement is false. But we could use an OR. I could just say num greater than 5 or num less than 10. Let's see if that works. Or you write with a pair of bars. That's right above the enter key. With OR, if either statement is true, then the entire statement is true. So now if I put a 3, it's not valid. Put 11, not valid. Put a 6, it's valid, but my program kept going. Got to switch these. All right, let's think about it logically. If I put a 3, 3 less than 5, that's true. And 3 is greater than 10, that's false. This is true. That will circle around again, that's good. What if we put in the correct number? 6 is less than 5, that's false. 6 is greater than 10, that's also false. So we'll break out. That should work. Do the 4, do the 11, do the 6, and we're good. All right, well played. Any questions? So that's the way to do it. You can set your conditions up. Understand that with OR, one condition has to be true. If any condition is true, the entire statement is true. With AND, they must all be true. If any statement is false, the entire statement is false. And you can chain these guys together. You know, you can have several ors, or you can mix it up with ands, and I recommend that you use parentheses if you start doing this. You can have more conditions out here. But there's really no limit on the number of operators you can chain together right there. And or are called logical operators. We had the comparative or the relational operators up here at the top. We also have the logical operators. This is logical and logical or. And there's also a logical not. Not flips the value. If it was true and you put a not in front of it, it's false. If it's false, you put a not in front of it, it's true. So if I say not true, that's false. And then if I said not false, that would be true. Logical, not. So there's your 3 of relational operators. You need to memorize those and what they do. And same thing with your 6 relational operators. And what does the break statement do? Breaks out of one loop. If you have a loop inside of a loop, it will only get you out of one. We have another statement that's akin to break. It's called continue. I'm going to leave this true at the bottom. I'm going to put my break statement back. Well, what do you think continue does? Doesn't the loop already continue by itself? It restarts the loop. It's the best way to think of it. It skips whatever code is remaining and it loops back around to the beginning of the loop. If you do this in a for loop, it ticks the counter one as well. Goes to the next iteration of the loop. It's weird that it's called continue, because your instincts tell you, well, it makes the loop continue, but the loop will continue all by itself, so that doesn't make any sense. Continue restarts the loop. You don't use continue very often. You don't see it used very often. I don't know that it's ever really needed. It is just something you can do. Any questions about chapter 3? We've got one more thing we need to cover in chapter 3, but I will probably save that for next week. I didn't cover switch statements, so we'll look at switch statements next week. For right now, let's look at the lab. Write a program that will calculate the payroll for a small company. Prompt the user for the employee's ID, the rate of pay, and the number of hours worked. What are those data types? ID number, what data type? Integer, integer should work just fine. Rate of pay, double or float. Number of hours, double or float. Float's fine for hours. Remember, doubles are for really large decimals. You can use a double if you want to. There's nothing wrong with that, but a float would hold any number of hours that you could work in a week. What's the most hours you can work in a week? Huh? It's like 168. 7 times 24. That is the most hours you can work in a week. So yeah, decimal, integer. After processing the data, ask the user if there are any other employees they need to process. So you're going to be running this program in a loop. If so, repeat the scenario. You're required to use the do loop. Inside the program, you need to make some calculations. You need to calculate the gross pay. What is gross? That's the total before the government takes all your money. And you account for federal taxes, FICA taxes, Medicare, and you calculate the net pay. The net pay is actually what you get to take home after all the taxes have been removed from the gross. You've got a little table at the bottom here that determines what tax bracket you fall into. So you'll need to base your total taxes on that tax table down there. You can use if statements or you can use a switch. Like I said, I'll be covering the switch next week, but if you want to use a switch, you can look at the book, or if you remember how to use a switch from intro or from programming logic and design, then you can use a switch as well. If statements are a little better, I think, for this program. Make sure that your program handles overtime. So if an employee works more than 40 hours, he's entitled to overtime. That's time and a half. Your program needs to account for that. If you don't pay your employees the overtime that they work, they will get angry. Very angry. Alright, once you've made all your calculations, you want to display all the data to the user in a professional format. Round your decimals to 2 decimal places. Does anyone know how to do that? Remember how to do that? If you want decimals at 2 decimal places, you need to come up to the top here, pound include IO manipulator, IO manip. And then somewhere in your program, have a cout statement that says set precision however many decimal places you want, and then another insertion operator and type the word fixed, and that will hold it at 2 decimal places for the rest of the program. Show point will always show the point even if it doesn't have a decimal. What? Set precision is really all you need. You don't need show point. Any other questions?